Hello students, I am Isha Medarata. In today's video, we are going to discuss a topic called laser. So we'll be seeing what is laser, how is laser produced, what are the characteristics of laser, and we'll also be discussing three important processes which are very important to study laser, that is Einstein's processes. So let's start with what is laser. So laser is a device which emits light through a process of optical amplification which is based on stimulated emission of electromagnetic radiation. Now in this statement, stimulated emission is a word which will be explained in the later portion of this video. What is electromagnetic radiation? Electromagnetic radiation is nothing but light. It's a form of light. What is the full form of laser? So we all have heard this term many times, but you know, laser is an acronym which has a full form, and the full form of laser is light amplification by stimulated emission of radiation. So it is a form of light which is a sort of amplified light which is produced by a specific process called stimulated emission. So LASER means light amplification by stimulated emission of radiation. Now let's move on to the characteristics of laser. How laser is different from the conventional or the normal light source. So starting with the first characteristic, that is coherence. Now what do you mean by this word coherence? Coherence is a property in which the wave trains are identical in phase and direction. Now, we know that light is a form of wave, an electromagnetic wave. That is, to be very precise, I would say light is a form of transverse wave. It always flows or propagates in the form of crests and troughs. And light has small particles called photons. All these photons, they move together. So, you can say it comprises of all photons moving together like waves, and this is what is known as a wave train. So, if the wave trains are identical in phase and direction, that means if all the photons travel in the same direction, in the same phase, we say that this is coherence. All constituent of the laser beam, all constituent photons of the laser beam, they possess same energy, momentum, and they propagate in the same direction. So this is what coherence is. Let's have a look at the diagram. So in the diagram, you can see that there is a normal light source, an incandescent light source is shown, which is incoherent. How can I say it is incoherent? So from the diagram, you can clearly see that all the photons are scattered in different directions. Whereas below, the diagram of coherent light source is shown like a laser. You can clearly see from the diagram that all photons are in same direction. They are traveling in same direction. They are traveling in same phase. Clear? So this is the meaning of coherence. I will be showing you an animation in which there are two types of light sources shown. So first we will be seeing what is incoherent light. You can see the excited atom liberates photons in different directions. So this is a normal light source. Can you see photons scattered in different directions? They are not traveling in the same direction. But now on the other hand, if I have a coherent light source like this, you can clearly see from this video that all photons are traveling in same direction, they have same phase and they have same momentum. So such a type of light source is called a coherent light source which travels as a clear beam. So this is laser light and this is normal light. You can see from the video that normal light has scattered photons whereas laser has photons traveling together. Now, because of the property of coherence, laser can be amplified. Why can I say laser is amplified? Because if all photons have same phase, all have same momentum and all travel in same direction, this can be easily amplified. So, because of this property of laser, it can be amplified. Moving on to the next property of laser, that is high intensity. Now, due to the property of coherence, because we know that all the constituent photons travel in same direction, all of them move together, so laser can focus on a very, very small area. How much small? As small as 10 raised to minus 6 centimeters square. So it is less than a dot. It's a very small area. That means the entire light energy can focus on a very small dot-like point. This is known as extremely high concentration of energy in a very small area. This is the meaning of high intensity. Because laser beam is highly intense, because all the energy can focus on a very small area, you can say that laser can be used in welding, drilling, cutting. So it has an industrial application because of this characteristic called high intensity. Moving on to the third characteristic, that is high directionality. Directionality means all the photons should be in the same direction. Now, if you consider a normal, an ordinary light source, it emits light in all possible directions. But on the other hand, a laser source, it travels as a parallel beam over a long distance without spreading. Now, why doesn't a laser spread? A laser doesn't spread because it is coherent. So, these two properties I can say are interrelated. An ordinary light radially spreads after a distance of d square by lambda. Lambda is the wavelength of light and d square is the diameter of the source from where the light has come out. The angular spread is given as theta by d. So, theta is the angle at which the light is emitted from the source. Now, I have a diagram to explain what exactly is the spread of laser. So, you can see in the above diagram, there is a normal light source which is spreading when it emerges from the bulb. But on the other hand, the bottom portion shows a laser which shows that all the photons are coherent, they are moving together. Now, the second diagram shows that there is an ordinary light source. You can see that if the light source is thrown to a distance of 2 kilometers, it can spread up to a distance of 2 kilometers. Whereas on the other side, if you see laser light, if it is spread at a distance of 2 kilometers, you can see the spread is as small as 1 mm. Because of this property, the laser is used as a ranging device. It is used for even interplanetary communication because it doesn't spread, it doesn't scatter, and that is the reason all the information remains together. Now, coming on to the last property, the last characteristic of laser is high monochromaticity. What do you mean by the term monochromaticity? So, monochromaticity refers to a pure spectral color of a single wavelength. Now, we know the absorption spectrum. The spectrum has basically 7 colors, right? Each color has a specific wavelength photon emitted. Now, monochromaticity is only defined when we refer to color of single wavelength. Degree of monochromaticity depends on the wavelength bandwidth of the wave. If the wavelength bandwidth is very narrow, higher will be the monochromaticity. Obviously, if the wavelength range is very, very narrow, that means it resembles only one wavelength. So, we say that higher monochromaticity is there. Laser has a wavelength bandwidth of around 100 nanometers, or I can say 10 raised to minus 7 meters. It is very, very small. So, if the laser light is of red color, all the photons will have a wavelength close to red. That means the source is highly monochromatic. This is a diagram which can show you that this is a white light. When it is thrown through a prism, it will scatter into 7 colors, the Vibgyor, the 7 colors. But on the other hand, if you have a monochromatic source like a laser, suppose here there is a red laser light is shown. So, passing through a prism also you get only single colored light, that is red. So, this is the meaning of high monochromaticity. So, these were the 4 characteristics of laser. Now, I'll move on to the second portion for today, that is Einstein's processes. According to Einstein, whenever radiation and matter interact with each other, 3 processes are likely to occur. So, Einstein said that if you are considering radiation and matter, whenever radiation is interacting with matter, there can be 3 processes occurring. Now, if I'm saying three processes, but basically either the matter is going to absorb energy from the radiation or the matter is going to emit energy. Now, according to the basic absorption and emission, Einstein proposed three processes. Let's see what are these three processes. The first one is induced absorption, second one is spontaneous emission, and third one is stimulated emission. We'll be seeing all these processes one by one. Now, to explain the three processes, there are some assumptions which are important. So, I'll be assuming E1 as the lower energy level, E2 as the higher energy level. To explain the processes, I'll consider only one atom and the difference of these two energy levels, that is higher minus lower, is equals to h nu, and h nu is generally denoted for energy of photon. So, now let's begin with the first process, that is known as induced absorption. What do you mean by absorption? It will be a process which will take place from lower to higher energy. So, when your atom is in the lower energy state, when it is not having any energy, if you expose it to radiation, the atom is going to absorb the energy of radiation and it will be excited. So, let's see what induced absorption is. So, if a photon is incident on an atom which is in a lower energy state, the atom absorbs the energy and excites to a higher energy level called induced absorption. So, this is the process of induced absorption. That means lower energy atom is taking energy and moving up. Let's understand with the help of a diagram. So, this is the situation before absorption. You can see from the diagram that atom is in E1 and we have already defined E1 as the lower energy level and the level E2 is empty. Now, let's see what happens if light is incident. If light is incident, this atom will absorb the light energy and it will move to higher energy level. Understood? That means I can say atom plus a photon gives me atom star. What is atom star? Excited atom or atom in the higher energy level. Now, the rate of this process, the rate of induced absorption R12. Why do we write 1, 2? Because the process is taking place from the lower energy level E1 to the higher energy level E2. So, it is moving from 1 to 2, so we write R12. Now, on what parameters this absorption depends? See, if there is only one atom and you throw light, only one atom is going to excite. But if there are 100 atoms can excite to the higher energy level. So, one parameter is number of atoms which are present in the lower energy level, and this number of atoms is known as the population of the lower energy level. It also depends upon the light intensity thrown. If the light is very dense, if it is having a great amount of energy, the excitation would also be higher. So, rate of induced absorption R12 is proportional to N1 into rho, where N1 is the population of lower energy level and rho is the density of radiation. If I remove this proportionality sign, I will introduce a proportionality constant which is known as Einstein's first coefficient, B12. Because the process is from 1 to 2, we use B12. What is B12? It is known as the probability of absorption per unit time. So, this was the first process proposed by Einstein. Now, let's discuss the second process, which is a type of emission. Whenever we have the word emission, means the process is going to take place from higher to a lower energy level. So, the process in which there is an emission of a photon when an atom transits from a higher level to a lower level without help from external energy. If the atom is coming on its own from a higher to a lower energy level, it is not taking any external energy's help, such a process is called spontaneous emission. What do you mean by the word spontaneous? It is sudden on its own. Let's understand with the help of a diagram. So, this is the situation before emission, that your atom is in the higher energy level E2 and the lower energy level is empty. But this happens after emission. The atom automatically, the moment atom rises to higher energy level, it is automatically going to come down without anyone's help. Such a process is known as spontaneous emission. The atom was at E2, now it has come to E1, means the difference of energy will be released, because we know that energy can never be destroyed. So that is released in the form of a photon h nu. That means I can say atom star means excited atom. When it comes down on its own, it gives a photon plus an atom. Rate of this spontaneous emission is given by R21 spontaneous is proportional to N2. What is N2? Number of atoms in the higher energy level. So if there is only one atom, I will get one photon. But if there are 1000 atoms and they come down spontaneously, they will give me 1000 photons. So R21 spontaneous is equals to A21 N2. What is A21? It is the second coefficient proposed by Einstein, which is known as the probability of spontaneous emission per unit time. Now let us move on to the third process which was proposed by Einstein. This is known as stimulated emission. What do you mean by the word stimulated? Something that doesn't happen on its own. You have to initiate, you have to push it so that it occurs. So this process in which there is an emission of a photon when an atom transits from a higher energy level to a lower energy level with the help of external energy is called stimulated emission. So there is only one basic difference between spontaneous and stimulated emission. Stimulated requires external energy. The term itself says you are stimulating, you are initiating with someone's help. So this is the process before emission, that the atom is in E2, higher energy level. Now before the atom comes down on its own, what I have done is, I have thrown a photon. That means I have given my atom a direction in coming down. In the earlier case, that is in the case of spontaneous atom, spontaneous emission, what used to happen? In case of spontaneous emission, what happens is that your atoms, when they come down one by one and release photons, all photons are scattered randomly. That means you get incoherent light. But for laser, we should have coherent photons. So in this case, what we are doing is, before the atom directly come on its own to the lower energy level, we guide it with the help of external energy, and that is with the help of a photon. So in this case, I can say atom star plus a photon means excited atom plus a photon is going to give me atom plus 2 photons. So my output is also doubled and my output has a particular direction. Now this rate of stimulated emission, it depends on two factors. One is the number of atoms in the higher energy level, and second is the density of radiation. So if I remove the proportionality sign, I write R21 stimulated is equals to B21 N2 rho, where B21 is known as Einstein's third coefficient. In today's video, we have discussed what laser is, we have discussed the 4 characteristics of laser, and we have also discussed the 3 processes proposed by Einstein and the 3 coefficients of Einstein. Hope you have understood all the topics I discussed very well today. Thank you.